Hello and welcome to Supply Chain Management, Session 1, Module 2. Now, before we move on with this module, let us recap what we did in Module 1. In Module 1, we had a brief overview of supply chain management where we looked at questions like what is a supply chain? What purpose does a supply chain serve? We talked about how is supply chain management different from supply chain, and then we discussed the goal, the basic fundamental objective of supply chain management. And finally, we ended Module 1 by discussing the different decisions which we take or encounter during our role as supply chain professionals. In this module, we are going to introduce you to what we call the process views of supply chains. Now, let me explain what we mean by views of supply chain. These are, supply chain is a concept which can be viewed from different perspectives. Okay, so if we look at the processes which are involved in the management of supply chain, then we can take two different distinct views or perspectives of these processes and the way they are organized within the supply chain. So let's begin. Two different, very important perspectives are called the cycle perspective or the cycle view of the supply chain and the push-pull perspective or the push-pull view of the supply chain. And we will begin our discussion with the first one, which is the cycle view of the supply chain. Now here, let us first understand this particular diagram. Now we have the supplier, manufacturer, distributor, retailer, and then the final customer. We have represented the supply chain as being, as constituting these 5 different layers or levels. Okay? We must point out at this stage that this is a very traditional view of the supply chain. In a country like India, for various products, essentially products which are meant for daily consumption, which you can buy at a local kirana, for example, you may have far more number of layers within the supply chain, because in India, we have multiple geographical markets. Within a region, you have sub-region. Within a sub-region, you may have different territories and so on and so forth. So multiple levels or layers could be there, but essentially what we are discussing here will still remain valid for that also. Okay, so with these 5 different levels or layers in the supply chain, we see there are 4 different cycles which are being represented in this figure. The customer order cycle is between the customer and the retailer. The replenishment cycle is between the retailer and the distributor, and then the manufacturing cycle between the distributor and the manufacturer, and finally the procurement cycle between the manufacturer and the supplier. The supplier here is the party which is sending components, raw material, essentially items which the manufacturer uses to build the final product. Okay. Now, although we have 4 cycles with 4 different names, each of these cycles is identical or very similar in many ways. So what is happening within a cycle? Within a cycle, we are saying that, it represents, a cycle represents a sequence of events. So what are these events? The cycle starts with the buyer within the cycle ordering for certain items, okay? The supplier within the cycle receiving that order and then sending those items in the quantity that is required by the buyer receiving all those supplies, and finally the buyer paying the supplier the money in exchange for the items received by the buyer. Okay, essentially that is what is happening in each of these cycles, because you will realize that in each cycle there is a buyer and a supplier. In the customer order cycle, the buyer is the customer and the supplier is the retailer. In the replenishment cycle, on the other hand, the buyer is the retailer and the supplier is the distributor. Similarly, in this cycle, the buyer is the distributor, supplier is the manufacturer, and so on. So essentially, each cycle has a buyer and a supplier, and the sequence of events is the same, that the buyer orders, the supplier receives the order, supplier supplies, the buyer receives the supply, and pays for the receipts. Okay? Good. Now, you might realize from this brief discussion that each cycle is actually a transaction. A transaction where it gets initiated with the ordering and is terminated or concluded by the final receipt and payment. Okay? And therefore, we need to measure the performance of each of these transactions, and the performance measurement could be in terms of the effectiveness of the transaction and the efficiency of the transaction. The effectiveness is that if there is an order, how closely have I been able to fulfill that requirement? Which means that have I been able to supply all the items which were ordered? Have I been able to supply all the items at the time which was expected by the buyer? Okay, so those are the measures of effectiveness, and of course efficiency we will always measure using cost, and we are saying that, okay, I have filled the order, which means I have fulfilled the requirement as expressed by the buyer, but at what cost? Okay, a cost becomes a basic measure of efficiency for that transaction. So we are saying that in the cycle view, we have multiple cycles taking place. These are transactions that are happening between 2 successive parties or players in the supply chain. Good. Now, having understood this basic view or this basic introduction to the cycle view, let us look at some important implications of the cycle perspective. The first important implication of the cycle view. Consider the demand for a certain product. Okay, the demand could be, let's take an example of a product of daily use. Let us say we are talking about a bar of soap, a bathing soap bar. Okay, now in this kind of an example, the demand for that particular brand, that particular SKU of soap actually happens only at one end of the cycle of all the cycles, and that end is called the customer order cycle. Okay? It is the customer order cycle which actually faces or encounters what we call the independent customer demand. That is the only demand that is independent in this entire supply chain. However, this demand gets translated upstream, in the form of orders which are placed by the retailer, by the distributor, by the manufacturer. By the retailer to the distributor, by the distributor to the manufacturer, and by the manufacturer to the supplier. Okay, each of them. So the demand travels upstream. The same demand which is the independent demand generated by the customer. Okay, so we need to understand this. Now, what are the implications of this? The implications are very, very serious. Okay, now, what we are asking is that if there is a demand, then the demand perhaps needs to be forecasted, and since there is only one demand, for one particular SKU, okay, is the entire supply chain going to rely on only one single forecast for that demand? Or are the parties independently forecasting their own demand? In reality, you will find the latter happening more often, which means that the retailer will forecast the demand for that item based on the forecast of the retailer. The retailer will order from the distributor. The distributor does not know what that demand is. The distributor can only see the orders which are coming from the retailer, and therefore for the distributor it is the retailer order which becomes the demand, and the distributor will forecast in future based on how the retailer has been placing orders historically. Similarly, the manufacturer will forecast the demand based on how the distributor has been ordering in the past, okay, and so on. And therefore, you will agree perhaps that it's very funny, and yet it is very prevalent as a practice that although there is only one single demand, the same demand is being forecasted independently by different players. And what is the implication of that? The implication is that as the demand travels upstream, it keeps on getting more and more distorted. Obviously, because look at the final demand at the customer level. The demand is fairly stable. For an item like a bar of soap, the demand cannot fluctuate too much, right? You will agree to that. However, what is happening? How is the retailer ordering for that soap to the distributor? The moment a customer picks up an item of soap, the retailer does not turn back to the distributor and say, can you please send me one item, one piece of this soap? No, it doesn't happen that way. The retailer will wait for enough number of soaps to have been consumed by different customers before placing an order for a bunch of soaps. And therefore, the order which goes or which travels to the distributor is a bunch. It's not one single continuous demand. It's a more aggregated level demand that travels up to the distributor. Okay, and when the retailer orders to the distributor, the retailer is ordering based on the forecast that the retailer has made, but the retailer always puts some buffer on top of that. Now that buffer becomes the actual demand for the distributor. When the distributor orders the same item from the manufacturer, the distributor will add another buffer on top of that. And therefore what we find is that the demand is getting distorted as it travels upstream simply because the information about the actual independent demand is not being shared across the supply chain. Okay? So that is what is happening in this case. Okay. Let us look at the order size and the frequency of ordering. At the customer level, we are talking about the customer order cycle. There, what is the size of an order for, let's say, a bar of soap? You know, a customer will probably buy 1 bar or 2 bars or 4 bars at a time. Okay, so that is the size of order. But when the retailer orders to the distributor, he's probably going to order far bigger quantity than just 1 or 4 bars. Okay, so the order size has increased. Similarly, the distributor in turn is catering to a number of retailers. Okay, and therefore when the distributor is placing an order onto the manufacturer, the order size further goes up. Okay, so therefore what we are saying is that if you look at the order size tends to increase as you move upstream into the supply chain. Okay, now just think about this. Since the flow rate of the material or the flow rate of this item of soap is a given across the supply chain, if the order size increases as you move upstream, obviously the ordering frequency is going to go down. You know, at the customer order cycle level, far more number of customers are coming and buying soap, you know, far more frequently. But the retailer places order at a frequency which is less than the frequency with which the soap is bought by customers. Okay, similarly, the distributor frequency is even less, and so on. So this is something that we need to understand about the supply chain. One direct implication of that is that if the order size is increasing upstream, then obviously the supplies made are decreasing, right? They are decreasing in bulk as the supplies move from the manufacturer to the retailer, right? And therefore, there is something very, very important we need to understand, and that is what is the role played by the distribution center. Okay, and distribution centers are playing a very, very vital role in the supply chain. And what is that role? Look at the inbound path, look at the inbound supply from the manufacturer to the distributor. Okay, these supplies are bulk supplies. These are big quantity supplies. So what happens? The retailer which wants the soap does not need that kind of quantity here. So obviously that bulk is getting broken into smaller quantities or smaller lot sizes at the distribution center. So the distribution center is taking big orders or rather supplies coming from the manufacturer and then breaking up those supplies into smaller sizes and then sending them to the retailer. And this bulk breaking is a very, very important function that is happening at the distribution center. There's something else happening at the DC which is equally important, and that is what we call sorting and combining. Now, what do we mean by sorting and combining? Imagine a particular distribution center. Let us say distribution center 1. Okay? Now, distribution center 1 is receiving products from manufacturer 1, manufacturer 2. We have shown only 2 manufacturers. There could be n number of different manufacturers who are supplying to a certain distribution center. And all of these supplies are coming in big bulk. Okay? Now, these bulk are broken at distribution center. But when the retailer orders, the retailer is not just ordering items of manufacturer 1, the retailer may be ordering items of a large number of manufacturers from the distribution center. And therefore, the distribution center is combining, sorting items based on the retailer order and combining those smaller lots together to send to the retailer. Okay, so two very, very important functions performed by the distribution center: breaking of the bulk, and after breaking the bulk, sorting in terms of how much of what is required by which retailer, and then combining those items together and sending to the retailer. Okay, so that ends our discussion, brief discussion on the cycle view of the supply chain. Now let us look at the push-pull view of supply chain. To understand the push-pull view, let us go through this simple example of different sandwiches which we see here on the screen. Now let me point out that we are looking at 4 different kinds of processes involved in the supply chain, and these are in a very simplistic way classified as buying of raw material, preparing components, and then finally assembling and the sale of that sandwich to the customer. Now, what do we mean by preparing of components? Well, preparing of components could be, you may buy onions and bread, loaves of bread and butter and different salads, etc., etc. You may buy from the suppliers and then prepare these inputs for making the sandwich. You may cut the onion, you may, prepare, cook the protein that you are going to put into the sandwich. You may mix certain sauces and so on. So basically you are preparing for making the sandwich. Okay, so here are 3 different situations. The first one at the top is a ready-made sandwich. This is an example where you walk into a store and sandwiches are already on display. You select what you want and pay the money. The sandwich is given to you. It is a ready-made sandwich. Now, in this case, what we are saying is that raw material, buying of raw material, preparing of components, and the assembly of those components into the final sandwich. All of these activities or processes have already been done before you buy. They have been done in anticipation of an order. They have been already done. They don't have to wait for an order. Okay? And processes which have been executed in anticipation of a demand are processes which are called push processes. The pull process, the only pull process in this particular case is the customer asking for a sandwich. Which sandwich, so that particular transaction has to happen after the customer has placed an order. So push processes are processes which happen or which are executed much before the order actually comes. They are executed in anticipation of the demand. Whereas pull processes happen only in response to an order. They cannot be executed until the order has been made. Okay? Good. So that explains. So essentially we are saying that, These are the push processes, and this is the only pull process. Here is an example of a sandwich. Let's perhaps consider sandwiches that we may buy at a Subway restaurant. Okay, most of us have been to Subway outlets and therefore may be aware that the raw material purchase happens in anticipation. Even the preparation of components happens in anticipation. However, the assembly of the sandwich is a pull process, because you are, as a customer, able to customize which combination of different raw materials, of different components you want in your sandwich. Okay? And therefore, you are able to customize the final product. And because of that, the assembly of the sandwich cannot take place in anticipation of an order. It has to be done after the order has been placed. So what we find in this case is that the final assembly and the sale are pull processes, whereas these two are push processes. Consider the third example, or the third case. Now here we are talking about a sandwich. I don't think any one of us would have had the opportunity of eating this kind of a sandwich, but we can always imagine. You know, this is a sandwich which even the sandwich maker doesn't know what kind of sandwich the customer is going to ask for. You know, at least in the second case, in the Subway example, you know, there are the choices are not infinite. You know, there are certain configurations that are possible, but that is a finite set of choice that the customer gets. But in the third case, the customer has infinite choice. The customer can create a sandwich of many different layers, different you know, ingredients, sauces, vegetables, proteins, etc., etc. Even the maker of the sandwich does not have any idea about what kind of sandwich the customer is going to ask for. And therefore, in this case, the only thing, the only process that the manufacturer or the producer can execute in anticipation of a demand is buying of raw material. The rest of it, the producer cannot start until the order has come. Okay? So here we find three different examples of push-pull, combinations of push-pull processes, and we find that you know, there are different meanings and implication of each of these combinations. Some of you may recognize that the first one, which is the ready-made sandwich, is a situation which in supply chain management or in operations management is known as make to stock. You know, bulk of the items that we consume, the example that we took of the soap, okay, all of those examples are make to stock examples. Okay, where the producer creates the final item in anticipation of the demand, and there you know, the item is waiting, the product is waiting for customers to come and purchase. Okay, so that is make to stock. The second one is called assemble to order or configure to order, and is an example where customers are able to choose the kind of sandwich or the kind of product that they want. Another example could be the Dell you know, machine, which you are able to buy online, where you go and configure your machine, what you want to be delivered finally, by Dell. And Dell will start assembly of that machine only after receiving the specific order placed by you. Okay? So that is called assemble to order or configure to order. The third example is you can't even assemble, you can't even pre-create, or I mean, you can't even prepare components for assembly. And this is an example which is called engineered to order. This is an example which is, say for example, someone is getting married, and let's say a lady in this case, and the lady wants a gown for her wedding, or a dress for her wedding, which is very, very exotic, which the lady gets designed by a designer, so even the designer doesn't know what kind of dress the lady wants. So that's an example of engineered or designed to order. Okay? Now, the boundary between the push-pull processes is simply called the push-pull boundary. Okay? Now, you might be thinking that what are the relative advantages or disadvantages of each of these configurations? So, fairly easy to understand. In the first case, what is the disadvantage for the customer? The disadvantage for the customer is that the customer doesn't get choice, or the choice is very limited. In the second case, the choice is much larger. In the third case, the choice is even bigger. You can even go and design the kind of product that you want. So those are the advantages for the customer. What about the producer or the supply chain? Well, in the first case, the issue of the issue faced by the supply chain is forecasting the demand. Remember, everything is produced in anticipation of demand, and therefore demand has to be forecasted. And any forecasting of demand is essentially going to be erroneous. We have done that in our earlier course. So all forecasts have error, and therefore the problem for the producer or the supply chain in the first case is that of forecasting and forecasting error and accuracy. And how much inventory do I maintain of the final product? So those are the kind of issues that the supply chain faces. In the second case, the supply chain is providing greater flexibility, okay, but there is a problem here. The problem is that the waiting time for the customer increases, as compared to going and straight away purchasing a ready-made sandwich. In the second case, the customer first chooses what kind of sandwich she wants, and there is a period of waiting before that sandwich is delivered. Similarly, if you consider the Dell example, you can configure your computer online, but you may have to wait for a week or 10 days before it reaches you and you are able to use it. Okay? In the final case, the issue that the supply chain faces is a high degree of uncertainty. I hope you realize that. You don't even know what kind of product the customer is going to ask for, what kind of design the customer is going to ask for. And therefore, there's a lot of flexibility that you are creating for the customer, and that flexibility in turn means a lot of uncertainty in the demand for you. So those are the implications of the push-pull view. Yeah, so just to summarize, we are saying that look at the push processes. These are executed in anticipation of demand, and therefore demand must be forecasted. This is a proactive process. Proactive simply means that I am doing things before I am required actually to do, being proactive. Uh, uh, Suitable for what kind of demand? What kind of demand do you think will be more suitable for push processes where you are forecasting and keeping things ready for the customer to walk in and pick up? Essentially, we are talking of demand where the volume is fairly big, and the demand which is more or less stable. So items where the demand is big in size and stable over a period of time are the kinds of demands which are best suited for push kind of processes or make to stock kind of configuration. What about the pull processes? Execution essentially is in response to demand or an order. Okay? Demand is known with certainty. When you are executing a push process, demand must be known with certainty. There is no forecast here. The actual order. Okay? It is reactive in the sense that you are responding to the demand after it has happened. What kind of demand do you think this will be more suited to? Obviously, a demand which is more uncertain. If the demand is fluctuating a lot, that kind of demand, you want to create a lot of inventory stock and making that stock available. You just don't know how much stock to make available for meeting that demand. Whereas if you hold back, if you don't meet the demand directly but wait for the demand, okay, so that you are able to configure or assemble based on the demand, you may be able to meet a wider range of demand, and which is essentially what we are saying, that wherever the demand is more variety based, more fluctuating, those are the kind of more uncertain demand is where we will employ the pull processes more. Okay, and like I had said, that the push-pull boundary is basically the meeting point or the interface between the push processes and the pull processes. Good. So that brings us to the end of this module